So for geometry, unit 9, day 8, we're going to talk about inscribed polygons. In each diagram below, triangle ABC, we notice that in every one of these situations, the diameter is one of the sides of this triangle. And we know that an inscribed angle is going to be half of the intercepted arc. So every time this inscribed angle is going to be a right angle because it is half of a semicircle. So that's why ABC is a right triangle. Right triangles can be inscribed because the right angle is inscribed it's inscribed in a circle.
Mr. Weber, you aren't sharing the screen.
So when we look down here, we notice we have a diameter that comes all the way through. And we notice that in this case, it's angle A, and we have one side that's coming up to point C, and another side that's coming up to point B, which are the endpoints of the diameter. Therefore, angle CAB is going to be half of the 180. This is half a circle. It's the other half compared to the diameter. So the inscribed angle equals half of the intercepted arc. Angle ACB is the other angle of your right triangle. Here we have 50, so we know that the other acute angle is going to be complementary, so that's going to be 40. Then we have an arc CAB, and we notice using our eyes, you can trace it with your pencil, you can trace it with your finger, and you notice that that is again half the circle, so that's going to be 180 degrees. Then we're looking at arc AB. Arc AB is the portion here. Well, if you notice the angle that touches at the ends there, that's over here, we determined that that was going to be 40 because the acute angles have to be complementary in a right triangle. So the intercepted arc is double that angle. We come over here to the next one, and we see that we have a diameter, and this inscribed angle is touching the endpoints of the diameter. So that's going to be a right angle. And then for angle CAB, it's going to be complementary with the 64. So 90 minus 64 is going to be 26. So that has to be 26 degrees. Angle ACB, we've already talked about being 90. Arc AB, that's probably not the right terminology, all right? Because AB, two letters should always imply that it is less than 180 degrees for an arc. That's what two letters, so that's not a good notation. Could be ACB, that would be okay. But still, let's call it ACB, just so we're being sure that we're using the right notation. That would be 180 degrees. arc CB is going to be double the inscribed angle. So 52. Now we come on over to another diameter that we have an inscribed angle that touches the endpoints of that diameter. So we know we have a right angle. So ACB is 90 degrees. That means the other two angles are going to be complementary. That means half x plus 1/3 x plus 5 is going to equal 90. Those two angles, the acute angles of a right triangle, are going to be complementary. They're going to add up to 90. So there's a couple different ways we can do this. We seem to have fractions involved, okay? So there's a couple different ways we can deal with that. We need to add those two fractions together. So we need to make them be common denominators. So remember, to get them to be common denominators, it's good if you can think of a number that both 2 and the 3 both go into. So they, of course, both go into 6. So if they both go into 6, we need to make the denominator 6. So we're going to multiply the top by 3 and the bottom by 3. That's multiplying that fraction by a value of 1, and 1 doesn't change its actual worth. It just makes it look a little bit different. So now we have 3 over 6x. In the next one, we have 1/3. We need to make that denominator a 6. So I'm going to multiply the top by 2 and the bottom by 2. That is multiplying that fraction by a value of 1. And when you do that, you don't change its actual value, what it's worth, but it does look a little bit different. This is 2 over 6x. And we add 5, and it equals to 90. Now we have common denominators. Now we have like terms. So we can say 5/6 x plus 5 equals 90. Okay, there's a little fraction lesson for us. And we can subtract the 5. Leaves us 5 over 6x equals 85. Well, there's a couple different ways, again, we can handle this one. We could turn it into a proportion, all right, and we would cross multiply. That would always be a good way to handle that. That would be 5x, and we're going to multiply the other side by the denominator. So we take our 85 and we times it by 6. That gives us 510. Five goes into 5 once, 5 goes into 10 2 times. So x is going to be 102. That's not 102 degrees. Okay, x isn't degrees. X is 102. Then we can say half the 102 is x. Or half 102 is the degree value. Okay, but that they're not asking what the actual angles are. That was a tricky one. Any questions with that? All right. In a right triangle, a right triangle is inscribed in a circle. The radius of the circle is 7.6 centimeters. What is the length of the hypotenuse? I have no idea. How could I know? It seems like there's an infinite number of options. But for you to have a right triangle, you have to have an inscribed angle that touches the endpoints of that diameter. That's the only way you can get a right angle inside the triangle. Every other angle that you would make that doesn't touch the endpoints is not going to be a 90-degree angle. The radius is 5.6. So we know that the hypotenuse is going to be double that. And the hypotenuse is the diameter. I totally agree. Good job. 11.6 would be double the radius. Oh, yes, 11.2. It's 5.6 times 2 is 11.2. Good call. All right. Now, when we inscribe a quadrilateral inside of a circle, we have lots of different rules that happen for that. A quadrilateral can be inscribed in a circle if and only if the opposite angles are supplementary. So every triangle, any triangle that you make, can have its endpoints on a circle. Okay, every triangle can be inscribed in a circle, but not every quadrilateral can be inscribed in a circle. There are some quadrilaterals, how you might make it, it wouldn't fit inside. All 4 vertices would not touch the edge. But every triangle will, and I can show you more about that. Here we know D, E, F, and G all lie on the circle if and only if we know that D plus F is going to equal E plus G. And in both cases, those are both 180. The opposite angles are supplementary. So that's the main property that you're going to need to be able to solve a lot of these situations. So determine whether the quadrilateral can be inscribed in a circle. So I look here at the opposite angles and I notice that 130 plus 70 equals 200. Not supplementary. So it cannot be inscribed in a circle. It's not supplementary. One set of those angles was not supplementary. Therefore, the other's not going to be either, right? But that doesn't matter what the other ones were. These are not. Now we look at it and we know that we do have a set of opposite angles that are supplementary. Now, how do we know the other set has to be supplementary? Well, if a quadrilateral has the rule that it's going to be adding up to 360 and 2 of them add up to 180, that means the other 2 have to add up to 180. So we have 90 and 90 that add up to 180. So yes, it is supplementary. So it can be inscribed in a circle. Now we look here. Anyone know what type of shape this is? It is a trapezoid. We have one set of parallel sides. We know that because the sides have arrows on them, which implies that they are parallel to each other. Okay, and in that case, when they're parallel, we have the, well, we're supposed to think about the three types of angles, or the type of angles that are formed. And that's when we come up with this list right here. If you have parallel lines, if you have parallel lines, you're supposed to be looking for one of these four types of angles. Corresponding angles are on the same side of the transversal, on the same side of the parallel line. So they'd both be on top of the parallel line. That's not what we have here. Alternate interior, that's the type that make the zigzag. Alternate exterior, well, the 120 is an interior, so it's definitely not exterior. Then consecutive interior, oh, that's going to be this guy. Consecutive interior angles are going to be supplementary. So this has to be 60. So that angle there is going to be 60. Notice that we have dash marks on the legs of this trapezoid. That's making it an isosceles trapezoid, which means that the base angles are congruent. So yes, you have two sets of opposite angles that are supplementary. So it can be inscribed in a circle. So let's come down here, and I'm going to give you a shot at looking at questions A, B, and C. You can hold off if you want on D and E. Those are definitely more tricky, but you go ahead and try A, B, C. If you're watching this video, you're welcome to pause it, work on those problems, and then come back and visit to see what type of results we got. Now, as we come back and we try to solve these, we see that this is a quadrilateral, it has four sides, and we know that opposite angles have to be supplementary. They have to add up to 180 degrees. So for them to add up to 180 degrees, then we have to calculate what y is going to be. So it looks like y is going to be 118 degrees. Then as we come across and calculate the x, we're going to use the same rule, which is going to have the same calculations. So x is also going to be 118 degrees. So how we did this was looking at the opposite angles. Because the quadrilateral was inscribed in the circle, we know that opposite angles add up to 180. So let's jump over to letter C next. That's probably the next easiest one. And the opposite angles, again, this is a quadrilateral. It's touching the sides of the circle. So opposite angles are supplementary. That means the opposite angles will add together to equal 180 degrees. So we've got 8x, -6. So first I collected like terms. The 3 and the 5 made the 8. The -8 and the 2 made the -6. I add the 6 across. Divide by the 8. I know that 8 goes into 18 2 times, which is 16, leaves me 2 left over. 8 goes into 26 3 times, which is 24, so there'd be 2 left over. So you could call that 23 1/4, 23.25. That would be the value of x. Now we look at the very last one here. So this seems a little trickier because we can't just do opposite angles. Opposite angles are supposed to be supplementary, but I don't know what x is. I have 2 unknowns for those opposite angles. But let's take a look at what we actually know. If it is 170 to get to here, and 40 more to get to there, that should be 210 to get all the way to the edge, from R all the way around to T. So that would be arc RST. Well, angle X touches at those 2 spots. So X is going to be half of 210. So X is going to be 105. Now, if you know that X is 105, you know that X plus Y has to be supplementary. You plug in your 105, and when you subtract that, we should get 75. So Y is 105, and actually X is 105 and Y is 75. Now come the 2 toughest ones. Well, we're kind of up against that same pressure. Knowing that opposite angles are supplementary. Well, we have 2y here. We have 3y plus 5. So we know that those angles, opposite angles, are going to be supplementary. Because they're the same variable, I can add them together and equal them to 180. So that gives me my 5y. Subtract the 5y and divide. 5 goes into 17 3 times with 2 left over. 5 goes into 25 5 times. So we know that y has to be 35. How did we get that? We knew that the opposite angles were supplementary. And if they are the same variable, then you can go ahead and work with the problem. But what happens to be tricky is when they are different variables. That's 2 unknowns. And you cannot collect like terms. But look at X. X opens up and touches here. X opens up and touches here. So that looks like 183. Right. So if we know that X is going to be half of 183, that's going to be 91.5. So X is 91.5. We know that X plus Z is going to add up to be 180. 91.5 plus Z must make 180. So when we subtract that across, we get 88.5 for Z. So definitely a little bit different there. Take a look at what we did. How did we start that off? We know that opposite angles are supplementary. So we were able to do that with the Y's. But when it came to the X and the Z, there were no like terms. You couldn't collect like terms. So we noticed that the X touched the circle in two different spots, and we could take half of that arc, and that got us going. So let's take a look on this last one. Well, looking over here, that looks reasonable to solve for. Opposite angles are supplementary. So we 3x plus 36 or 63 has to equal 180. Get 117. And we divide. 3 goes into 11 3 times with 2 left over. 3 goes into 27 9 times. So X has to be 39. Then we can come around and go the other direction. Those two angles have to be supplementary. If a quadrilateral, let me write that out for you. If a quadrilateral is inscribed in a circle, that's what we've got in every one of these cases, then the opposite angles are supplementary. All right, that's an important theorem that we're working with. So then this last one, we know that we have 4y minus 1 and the 65. That has to add together to be 180. So you have some like terms to deal with. And we move that across. And we divide by 4. So 4 goes into 11 2 times, which is 8. That leaves with 3 left over. So 4 goes into 36 9 times. So you've got your two variables, 29 and 39. Okay? That is what we have with inscribed polygons. Good job, everybody. And then looking here at our last question. In the star, all the inscribed angles are congruent. Okay? Find the measure of the inscribed angle. Then find the sum of all the inscribed angles. So what we're looking at is trying to determine what angle that is right there.
I have the quickest way out. Unfortunately, it's 2.
What do you think?
There are 5 angles in Inscribed. They are all congruent.
So this one is opening up there. This one is opening up here. This one is opening up there. This one is opening up here. And this one is opening up there.
No, 180.
So looking at the whole circle, we have 360 degrees all broken in to 5 equal pieces. So 5 goes into 36 7 times with 1 left over. 5 goes into 10 twice. So every one of these would have to be 72. Because remember, they told us that they were all congruent. So each one of those angles is going to be half the intercepted arc.
Yeah, in the case that I was going to do, all the angles separated, and therefore, well, all the angles would add up to 180. And I divided that 180 by 5, and I got 36.
Seems very good. So be sure we answer the question. Find the measure of an inscribed angle, that's a 36.
Yeah, I just gave away the last part of the question.
Then find the sum of all the inscribed angles. That would be 36. And there are 5 of them. And we notice that they are going to add up to half of what the whole circle does, because when you look at each one of those, they cover 1/5 of the whole circle, and half of that is 180. So there are 5 of those. 5 times 36 is 180.